Hello, my name is Komal. I'm an applications engineer here at Maxim Integrated. In this video, we'll discuss the features and application of Max 14916, and I'll also demonstrate how to get started on its EV kit to verify the device's capability to provide 2.4 ampere minimum current per channel in quad configuration. First of all, going back to the basics, we know that a transistor or MOSFET can be used as a switching device in a circuit. The location of the transistor determines the type of switch.
When the transistor is connected to ground, that means the load is between the positive voltage and the transistor. Since the transistor is switching the path to ground or is sitting on the low side of the load, it is called a low side switch. When the transistor is connected between positive voltage and the load, this configuration is called the high side switch, since the transistor is switching the path to a higher voltage than ground and is sitting on the high side of the load.
In circuits where the load is connected to a single supply voltage, such as a car where the battery voltage is fixed and the body is grounded, the output can become grounded. In such applications, high side switches are used as they can detect abnormal conditions such as ground faults.
The Max 14916 has 8 high-side switches which can deliver up to 1.1 ampere continuous current per channel. The two adjacent channels can be paralleled to form 2.4 ampere high-side switches. The high-side switches have maximum on resistance of 250 milliohm. The device also has addressable SPI interface for global and per channel configuration and diagnostics including under voltage detection, open wire or load detection, overload and current limiting reporting, thermal condition reporting, and more. The Max 14916 is most suitable for industrial digital outputs and PLC systems. The Max 14916 EV kit in conjunction with the USB to GPIO adapter board provides easy to use and flexible solution for evaluation of the Max 14916.
So let's get started. So I've made the connection on the board here, as you can see. There's a 24 volt DC supply which is plugged in to the board through J1 and J2 plugs, and the USB GPIO2 board is connected to the PC via a 5 volt USB cable. We can download the GUI from the website through the links given in the description box.
Start the graphical user interface, also known as the GUI. Power up the supply and select Max 14916 from the pop-up menu. Verify that the status bar indicates the EV kit hardware as connected. The GUI automatically detects EV kit is connected to the PC and enables serial communication. For the demonstration purposes today, I have used the default jumper positions. So let us check the GUI out. The Systems tab provides system-level control of the selected output pins, including static and dynamic control. The Register Setting tab provides per channel and enhanced diagnostic configuration. The diagram on the GUI depicts a very basic communication block diagram inside, and you can see the two adjacent channels are paralleled to form a quad output configuration. Each output can be configured on, off, and a square wave of varied frequency can also be driven across each switch, which we'll just see in a minute. Any configuration change can be made in the Register Setting tab.
Onboard diagnostics provide VDD status through communication error LED DS18 and a global fault condition via fault LED DS19.
Press the Read All button twice to clear the initially detected under voltage global conditions in the global ERR or the global errors register.
Let's try a few register changes. I want to change all the output switches to on state. To allow the status LEDs and fault LEDs to be controlled autonomously by internal logic, we need to disable the S LED and F LED set bits in the config1 register. Click Write Modified. Now I can go ahead and change all the output switches to on state by changing the setout register by typing in 255. Please note that the GUI accepts decimal, hex or binary numbers. Click Write Modified to write a new configuration into the register. This can now be observed on the EV kit as per channel output state are visible via LED matrix DS1 through DS4.
For our second test, I'll drive a square wave across output 1 and we'll verify it on the oscilloscope. The frequency I've chosen is a little over 10 kilohertz.
So as you can observe, I'm using an inductive load of 1.5 Henry and driving a square wave of roughly 10 kilohertz.
Let's drive a square wave across two outputs now. I'll change the GUI again to drive out 1 and out 2, both with 10416 Hz, and I'll drive the frequency.
So now I'm driving two outputs, one with inductive load and the other with no load, both of them with square wave of 10 kilohertz, and it can now be observed on the oscilloscope.
Each SPI transaction is displayed in the device mode.
Feel free to drop your questions to the technical support portal and have fun evaluating. Thank you for watching this video. For more information, refer the datasheet. All links are in the description. Have a good day.